All right, today we're going to look at topic 8.3, which is using accumulation functions and definite integrals in applied context. This topic is really just kind of like a summary of a couple different things and how we're going to use them in very AP style questions. So this topic revisits an idea that was previously introduced back in Unit 6 with topic 6.4 because of its consistent presence on the AP Calc exam. We're going to take a look at it again. Example 1 says the graph of f prime, the derivative of f, is this line shown below. If f of 0 is 5, what is f of 1? So what we would want to write here is what we called back in topic 6.4 an accumulation function. Okay, so we're trying to find f of 1. Let's start with the function f of x. Okay, so f of x would equal to what starting point we have would be 5 plus some integral from 0 to whatever we're looking for. Now, we can't figure out exactly what we want to do, which is any number, so we'll call it x, okay, of f prime of x dx. But remember, when we talked about this back in 6.4, we can't use the same variable here, so we can use any other variable that we want. Let's call it w, f prime of w dw. Okay, if you don't like w, use another variable. Just don't use x and don't use y, okay? So now if we're trying to find specifically f of 1, we can say, all right, f of 1 would equal 5 plus the integral from 0 to 1 of f prime of x dx. Now we can call it f prime of x because we're no longer using x in the integral. And we can do this, since we don't have a function for f prime, we can do this using geometry. So it's a triangle. So 1/2 base height, which would be 3. So f of 1 would equal 8. And this is, again, called an accumulation function because we're accumulating something. In this case, we're just accumulating space between our two y coordinates. Here's some practice with that. The graph of f prime, once again, shown here on 0 to 9. Given that f of 3 is 5, find f of 0, f of 7, and f of 9. All right, so first of all, if f of 3 is 5, f of 0 would be 5 plus the integral from 3 to 0 of f prime of x dx. Now, we talked about this before. When we do problems like this involving a picture, we do want those bounds to be in numerical order. So let's switch them. And make sure you switch the positive to a negative out in front. So now it's 5 minus the integral from 0 to 3. And the integral from 0 to 3 is 4. So it's 5 minus 4. F of 0 must be 1. For f of 7, that would be 5 plus the integral from 3 to 7 of f prime of x dx. So that's 5. The integral from 3 to 7 is 9, but it's actually negative 9 because it's below the axis. So that would be negative 4. So f of 7 is negative 4. All right, for f of 9, we can write that same integral down. So it would be 5 plus the integral from 3 to 9 of f prime of x dx. That would be fine. But there's actually a better way to do this one. Because we have an xy coordinate closer to 9 than 3, 5, a better way to do this would actually be f of 9 equals f of 7, which is negative 4, plus the integral from 7 to 9 f prime of x dx. Now, both answers will get us the same thing in the end, but if we do it in the blue method there, we only got to look at one area here, which is 2. So that'd be negative 4 plus 2. F of 9 must be negative 2. These last two problems that we're going to look at here are old AP problems off the AP test. So let's start with this one here. This is from 2010. Example 3. Talking about a zoo sponsoring a one-day contest to name a new baby elephant. Zoo visitors deposit entries in a special box between noon and 8 p.m. The number of entries in the box t hours after noon is modeled by a differential equation E. Values of E of t in hundreds of entries are given in this table below at 5 specific times. Question A says, use the data in the table to approximate the rate in hundreds of entries per hour at which entries were deposited at t equals 6. So we don't have a function for E, so we can't find E of t, so we can't find E prime of t. Okay, that's why this word is here. If we could find E prime of t, then we wouldn't need to approximate. But since we can't find E prime of t, we have to approximate. E prime would be the slope of the tangent line. Since we can't find that, we approximate with the slope of a secant line between the 2 points around 6. So we would say E prime of t is approximately 21 minus 13 over 7 minus 5, which is 8 over 2, which is 4. Okay, so again, let's figure out what this 4 actually means. That is 400 entries per hour. So at t equals 6, about 400 entries per hour are coming in. Question B, use a trapezoidal sum with 4 subintervals given by the table to approximate 1 over 8, the integral from 0 to 8 of E. Use correct units and explain the meaning of it in terms of number of entries. Well, as soon as we see that 1 over 8 times the integral, we know this is an average value, right? So it's going to be 1 over 8 times, now we're going to use a trapezoidal sum. So 4 trapezoids, 1, 2, 3, 4. First trapezoid would be 1/2. The height would be 2. Bases are 0 plus 4. Second trapezoid, 1/2, height of 3. Bases 4 and 13. Third trapezoid, 1/2, height is 2. Bases are 13 and 21. And last trapezoid, 1/2, height of 1. Bases of 21 and 23. Okay, so that would get you can use your calculator to figure all that out. It would end up being approximately 10.688. Okay, what does that mean? That means the average, because this is an average value integral here. So the average number of entries that were in the box between noon and 8 p.m. is approximately, it's important to say approximately here because it's not exact, 1,068 or 1,069. Question C, at 8 p.m. volunteers begin to process the entries. They process the entries at a rate modeled by a function P, hundreds of entries per hour. According to the model, how many entries had not yet been processed by midnight? All right, so first of all, how many entries were there at 8 p.m.? There were 2,300 entries. So it's going to be 2,300 minus the integral from 8 to 12 of P of t dt, right? And since you have a calculator available to this, you can go ahead and type that into your calculator. Okay, and we should get approximately, actually, since this is all in hundreds, we want to just keep it as 23 for now. We should get approximately 23 minus 16. So again, approximately 700 entries. Question D, according to the model from part C, at what time are the entries being processed most quickly? So we want to know when this rate was the fastest. So we should probably find P prime and set that equal to 0. If you want to take P prime by hand and set it equal to 0, you can do that. If you want to just type that in your calculator and use the graph to find those answers, that's fine. Either way, you should get two answers for T, 9.184 and 10.817. All right, so now we can make a table for T and P of T. Remember, it could be an endpoint, so it could be at 0 or 12, right? Or it also could be at one of the two critical numbers. So then all you're going to do is take these numbers one at a time and put them in P of T. Oops, the endpoint's not 0, the endpoint is 8. Sorry. And put them in P of T and see what you get back. All right, I highly encourage you to try that on your own, make sure you're doing this right. And we should get 0, and then for the first critical point, 5.089. For the second critical point, 2.911. And for the last critical point would be 8. So when are they being processed most quickly? At midnight, because they're in a hurry now. Time is running out. Everyone wants to go to bed. So the entries are being processed most quickly at T equals 12 hours, or 12 a.m. I wanted to say that as well. Okay, our last problem, this is from 2010 as well. There is no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9, snow accumulates on the driveway at a rate modeled by F of T, cubic feet per hour. Janet she wakes up at 6 a.m. and starts removing snow at a rate of G of T, which is a piecewise function. So let's take a look at G of T first. It's 0 from 0 to 6 because she's sleeping. She's not removing snow for the first 6 hours. And for the first hour, she's got a lot of energy. She's revitalized. She removes 125 cubic feet per hour. Then she gets a little tired, so she slows down. Now she's removing 108 cubic feet per hour for the last 2 hours. All right, question 8. How many cubic feet of snow have accumulated on a driveway at 6 a.m.? So this is just how much snow has fallen. We're only looking at F, not of G. So this is going to be the integral from 0 to 6 of F of T dt. And since you have your calculator, simply type that in your calculator. You should get 142.275 cubic feet. Question B, find the rate of change of the volume of snow on the driveway by 8 a.m. Okay, so I think it might be a little bit easier to write an equation first for the amount of snow. The amount of snow at any time would be 0 plus the integral from 0 to t of f of x dx minus the integral of 6 to t of g of x dx. Let's take a look at that so we know what that is here. 0 because there is no snow at midnight. 0 to t because the snow started at t equals 0, started falling at t equals 0. And then subtracting because we're removing starting at 6, so from 6 to t of that. So this is an equation for the amount of snow at any time. So then the rate of change of snow would be a prime of t equals f of t minus g of t. That's just the second fundamental theorem of calculus. So if we want to find a prime of 8, it's f of 8 minus g of 8. Okay, so for f of 8, put 8 into this equation. For g of 8, we know it's 108. Okay, we should get approximately negative 59.593. Okay, what does that mean? Not that we're asked that, but we should always consider what that means. That means she's removing 59.583 more cubic feet per hour than is falling at that time. Question C, let H of t represent the total amount of snow in cubic feet that Jenna has removed from the driveway at time t hours after midnight. Express H as a piecewise function defined with domain 0, 9. All right, so we got H of t equals a 3-piece piecewise function. For 0 to 6, she has removed nothing. So it's going to be 0. But now for 6 through 7 and 7 through 9, we're going to have some functions there. All right, so for 6 through 7, if we have an accumulator function, so let's go h of t would equal h of 6 plus the accumulator from 6 to t of g of x dx. H of 6 would be 0, so it's just the integral from 6 to t of g of x dx. Because g of x is 125 there, it's going to be 125, so the integral from 6 to t of 125 dx. So that would be 125x from 6 to t, which is 125 times t minus 6. And that's going to be our equation right here, 125 times t minus 6. All right, now we would repeat that same exact process for the 7 through 9, but the only difference is we would have to, there's two differences. First, we'd have to add in the 125, because after 1 hour, she's removed 125 cubic feet. But also, this 125 would change to 108. So it would be plus 108 times t minus 7, because we're starting this one at 7. And that would be our piecewise function for h of t. Finally, question D, how many cubic feet are on the driveway? All right, well, good thing we already wrote this equation right here for the amount at any time. I'm just going to duplicate that and bring that down here. That's the amount at any time. So if I want to find at 9, I simply put 9 in here, and I get the integral from 0 to 9 of f of t dt minus the integral from 6 to 9 of g of t dt. The integral from 0 to 9 we already found earlier, didn't we? Oh, we did not, but we can find it pretty quickly by typing that in our calculator. And then the integral from 6 to 9, well, let's think about this. She removed 0 here. Let's go back up to here. She removed 0 here, 125 an hour for 1 hour, so that's 125. 108 an hour for 2 hours, so that's 216. So back down here, whatever this integral will be, which we'll put that in our calculator in a minute, minus 125 times 1 hour plus 108 times 2 hours. All right, we can type all that in our calculator, and our final answer would be 26.335 cubic feet. So at 9 o'clock, there's only 26 cubic feet left, which isn't that much. You can clear that up in maybe another 15 minutes or so. Okay, that is the end of the screencast today for topic 8.3. Thank you so much for watching this video, and I will hopefully see you again soon.